Okay, so let's get back to integration. Okay, a couple things to note. If we have an integral with a sum in it, then we can take the antiderivative of each separate function and add those together. You assume that that would be true, but now I'm telling you officially. Okay, you know what I'm going to write? Same is going to be true for subtraction, right? Okay. Here's something that kind of goes along with number 18 that we were talking about on the board. If we have an antiderivative that looks like this, it is the same thing if we pull that constant out in front and worry about the antiderivative and then multiply by that constant later. Yes, sir.
Just basically keep you on the first thing.
Carter, just say your question, please.
Is there a difference between like a K and a C you were using yesterday?
True.
Well, they both represent constants, and so I'm using a K so you don't get it mixed up with the plus C that we have to write when we find our antiderivatives. Okay. For what?
Or parentheses. I could say parentheses.
Yes, that too. I was worried about that.
Okay.
I'm just saying the thought never crossed my mind. But yes, that is true. Okay. Yeah. Just write it down. Okay.
Is that minus 7?
Yes. Okay, Carter, what did you say? We need to do what?
Just rewrote the square root x to the 1/2.
Okay, x to the 1/2, that would be helpful. What else is going to be helpful? Okay, x cubed over x squared minus 5 plus x to the 1/2 over x squared.
She's actually dividing by x squared.
Yeah, we're going to go and divide everything by x squared. That way we don't have to worry about fractions. And then, okay, and then why am I not writing as 7 over x squared? Okay, we want it to be x to a power in the numerator so we can apply the power rule. So, remember, when we do the power rule, we increase the exponent and multiply by its reciprocal.
And then plus C.
Yes, we're going to worry about that at the end.
You have to do that to each and every one, so it's plus C. It's going, in the end, it's going to be plus 4C.
But then when
Well-
all the seeds add up to be one constant?
Yes, that's very good, Jimmy. Okay, so we could say plus C, plus C, plus C, plus C. And yes, plus 4C we could write, but 4C is still a constant, okay? And so we're just going to write 1 plus C at the end because we don't know what that C is, okay?
Think about this one. You said that when we get to integrals, there's going to be some thing. We're going to have to multiply it and whatever that C is by 4 because we did the integral 4 times.
Or we can just write it as C and we can find what C is without having to worry about the 4. It's just a different C. It's just 4C. How do I want to do it?
4C is not the same as C.
Yes, it
is.
Okay, you guys are both right. 4C is not the same as 1C, is what he is trying to say. But 4C and C are both constants, and we just want it to represent a constant. We don't know what the constant is. So since 4C is a constant, Instead of writing 4c, we're just gonna write plus c at the end. Okay? Do you agree with negative 5x?
Yes.
What does this power become?
Negative 1/2.
And this becomes times negative 2 over 1. Minus 7 times x goes to the negative first, and we multiply by negative 1. So we have 1/2 x squared minus 5x minus 2x to the negative half plus 7x to the negative first plus c. Where did I get the what?
And going from the x to the negative 3/2 to the negative 2 times x to the negative 1/2, where did you get that 2x?
We have to add 1 to our power, and whatever our power is, we multiply by its reciprocal. Right? But over here, x squared, we multiply by 1/2. So since this is negative 1/2, we multiply by negative 2. Yeah? Okay.
Wait.
Is it all dividing? It would be a lot higher.
Multiply, we actually multiply all of it, I'm guessing.
Yeah, if you had a product inside, like if you had a polynomial times a polynomial, you're going to want to do the multiplication and then the power rule when you do the integration. Okay? Okay? All right, I'm going to put an integral up here. I want you to think about it for 30 seconds. I'm going to change this to a 5. I'm really sorry. I'm really sorry. I'm really sorry.
Looks
cool.
Ideas.
5x to the 1/2.
What? Okay. I like your idea, 5x to the 1/2.
Got a chain rule.
Okay. Now I don't necessarily want to call this the chain rule, but we need to think about how the chain rule would be applied when we go backwards. Now, first of all, let's worry about the power. We would have 5x to the 3/2 multiplied by 2/3. So there's our power rule. Now, we know that when we go backwards and find the derivative of this to get back to this red one, we would have to multiply by what?
5.
Okay, when we take the derivative, we would have to multiply by 5, right? So the antiderivative, since we have that coefficient, we would want to multiply by 1/6 to kind of cancel that out, right? I know you don't like that.
Wait, where's the 1/6 from again?
Like if we had,
You took the antiderivative of the outside, now we're taking the antiderivative of the inside.
well, like if we had 5x,
Yeah.
our derivative would be 5, right? So, maybe that's not necessarily what I want to see. How about this? Okay, if we had 5x raised to the 1/2 and we took the derivative, we would say 1/2 times 5x to the negative 1/2 times 5. Okay, so when we go backwards, we have to account for, well, we would have that chain rule there, and so we would need that 1/5 to cancel it out.
Wait, so
Okay.
is that like your answer then? Or is there more?
Well, we would just simplify it, right?
Yeah, but then-
So 2 over 15 times 5x to the 3/2 plus c.
Yeah, but then, what if you did the chain rule for that, you want to do?
Okay, well, let's check our work. Let's check our work. Derivative, we would take 2/15 times 3/2 5x to the 1/2 times 5 for the chain rule.
Wait, so wouldn't that be?
Yeah.
Be 1/5 times 5 1. You get that? Yeah.
Right? Now, this is only gonna work if we have like a coefficient on like a linear chain rule. Okay? It's not gonna work any other time. Okay? Yes.
I'm actually gonna have to disagree with you there again, because I just tried a different method and got a different answer. What I did was, I don't know if this
There is no other method.
are you sure? Because I think that's just enough. Sure your concepts are the same.
Like in the green? The green sheet just changed that. Or did I do a change?
Is this answer?
Well, you have the same thing as me, so 5 is 3 halves. 5 is 3 halves. 5 Oh. So I have 5 to the 3 halves. Okay. Which is 5 to the 3 halves.
Yeah. It's really bad.
Just like sitting there with and stuff, that way all walk in, just like, we need your help.
All right.
What is this? We talked about it yesterday.
That's the negative sign of x.
It's just sine, because the derivative of sine is cosine. Okay? What is this one?
Negative.
Because the derivative of cosine is negative sine. Yes.
We just have a refresh, a reason about, sure what the dx up there is. We're taking the
That's telling you, that's the differential telling you to take the derivative with respect to this.
So there's no numerical value to it at all?
Do we ever have to do dy dx?
Not in the same integral. This Hey, what is the derivative of tangent? What is the derivative of tangent?
Square, sine over cosine.
So what's the antiderivative of secant squared? Hello, Mr. Keller, may I help you?
The answer to this isn't in the back of the book.
No, not this one.
I would have missed this. What was the temperature? Can I talk to Aaron for just a half a second?
What's the,
Yeah, second.
That is not something we can do yet, but we will do it later. Okay? What is the derivative of secant?
Tangent, secant.
So the antiderivative of secant tangent is secant of x plus c. It is not negative.
That is cosine.
Do we have to see our version?
Like a what?
Negative.
X is getting kind of boring.
Let's just do c. Okay, for consistency. What's this antiderivative then, since you're on the wrong?
Cosecant.
Okay.
Use Q.
Yeah, I was using use X all the time, it's getting really
Can we
old.
use Q? It's typical.
Right.
no, let's use let's use.
Yeah.
What's this antiderivative?
Negative cotangent.
There we go, negative cotangent. These six you need to know.
Oh.
Well, duh, why do you think I'm writing them?
Somewhere else.
Jeez, people. Why would you not like this?
Can you go further? I wrote
I did, but it's so small and it's.
Okay. Can I come back to this during announcements time?
No.
Sure.
Yes, we have 2 more rules to go through. I will do examples through this. I told you, this is why I wanted to do tests at the end. You would Sis said that we do it before.
I said,
That was there, man.
No,
Okay, I'm gonna come back to this if you didn't write them down, okay? I will come back, I promise. So just skip a couple lines, we'll come back.
Keep going.
What is this antiderivative?
1/7.
Okay, positive sign. Positive sign.
hey, nice. That's good.
Sign of the.
Hold on, just look at it, think about it while some people are writing it down.
What to do it for?
Okay, so we have two antiderivatives that we need to think of. Jimmy, what's the antiderivative of cosine?
Oh.
Huh? Okay. Brady, antiderivative of tangent secant.
Would it be tangent?
Nope.
Secant.
Yep.
There we go. Sneaky.
All right.
500.
Is that a minus?
Yes.
So if the goal is just like break it up.
Yeah. So let's talk about this one.
It's square.
Theta squared times 1/2, because that's like theta to the first. Okay. Negative sine theta. Ooh, good job. Positive cosine theta. Negative cosecant squared is 3 theta. So let's,
And 1/3.
okay, I like the 1/3.
Let's go tangent.
Cotangent, is it positive or negative?
It's positive.
It's gonna go to positive because the antiderivative is negative, and it's already negative in there. Are you ready?
Wait, would you, so you do the chain roll, like chain roll the inside and just find the reciprocal?
Where does square go? Is there any something else doing there?
Times 1/2.
In the front.
No, because the derivative of cotangent is negative
Oh,
cosecant squared.
okay.
Okay, you can always check yourself to see if you're right. Take the derivative of your answer. Do you get back to what's inside your integral? Okay, that's kind of nice, right? Are you ready for the easiest rule ever?
Yes.
E to the x. Oh my god. Let's see.
I didn't even think of that.
So, question, e to the 4x dx.
To the 4x.
To the 4th.
Plus c.
Excellent. There's one more rule I need to talk about. What?
Logarithms.
Just the natural log.
Oh, well, then I said that.
Okay. Carter, what's the derivative of the natural log? 1 over x.
Does that have two things that this and does not have two?
The absolute value.
Write it down
I have a question. Could you just write that x to the negative first?
and add a power. What do you get? Okay. Now,
So just equal.
why do I have an absolute value inside of my logarithm? What's true about the domain of a logarithm?
Zero.
It has to be positive, okay? So since we don't really know what our denominator is, we have to say the absolute value of it so that the domain will be okay.
Could you also write that as like x to the negative 1 and then do like
Okay, add 1 to that for our power
it
rule.
equals 0? I
Okay,
just figured that out.
yep,
Sorry for being curious.
no, it's okay, I'm serious. Oh, you're reading that.
Thank you.
Okay, so the antiderivative of 7 over x dx. Okay, so if this confuses you, write it. You can put the 7 on the outside, and then 1 over x dx stays inside. And so then yes, you have 7 times the natural log of x plus c.
So does this deal with when you would have like x to the 0 if you tried to take it?
Yeah, we can't do x to the 0. Yeah. Okay.
Isaac Newton.
Actually, we didn't,
Didn't you just put,
it would have been,
Leibniz.
Leibniz. Everyone played the Leibniz, I can't remember.
So what's this antiderivative? It's 1 over something, right? So the natural log of x minus 5 plus c. Okay, as long as you have 1 over something linear, we can use the natural log rule.
so you can't have that 1/2.
If it's an x squared, then we would have to worry about the power rule, which is a great point. Last example.
No, this is bullshit.
Well, okay,
Bye bye.
so we don't have a quotient rule for antiderivatives, but what can we do? We can divide by x squared. So this would be the same as x to the negative 1
Plus 2 times x to the negative 2.
plus 2x to the negative 2. Now, anytime you have x to the negative 1, I would get in the habit of writing it as 1 over x. So you can recognize it as that natural log antiderivative. Okay? So, the antiderivative of 1 over x, natural log of x. Okay, plus 2 times, when we increase the power, we get
1.
x to the negative 1, and we'll multiply by the reciprocal. Okay. So we have the natural log of the absolute value of x minus 2 over x plus c.
So you can't take the natural log of.
Good afternoon, Killian Livingston Sound. It's time to rise up from your seats for the Pledge of
Because we have
Allegiance.
a power rule for that.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you very much. It's now time for your...
Okay.